Hello everyone, and welcome. Have you ever seen a simple white powder in an organic chemistry lab called potassium carbonate, or K2CO3, and wondered what it actually does? It shows up in so many different procedures. Today, we're going to break down the main jobs of this incredibly useful reagent. Let's get started. The most important thing to know about potassium carbonate is that it is a base. However, it's not a super strong base like sodium hydroxide. Think of it as a moderately weak base. This just right strength is what makes it so versatile. Its primary role is to act as a proton remover, or what chemists call deprotonation. It's particularly good at removing the acidic proton from phenols and carboxylic acids. Because it's not extremely strong, it's selective. It will easily deprotonate a phenol, but it won't typically deprotonate a simple alcohol, making it great for specific transformations. So, why do we want to deprotonate these molecules? This leads us to its second major function, creating powerful nucleophiles. When K2CO3 removes a proton from a phenol, it creates a negatively charged phenoxide ion. This phenoxide is a much better nucleophile than the original phenol. This is the key step in one of the most classic reactions where you'll see potassium carbonate, the Williamson ether synthesis. In this reaction, you mix a phenol, potassium carbonate, and an alkyl halide like methyl iodide. The K2CO3 first makes the phenoxide, which then attacks the methyl iodide to form an ether. The same logic applies to making esters from carboxylic acids. The K2CO3 deprotonates the carboxylic acid to form a carboxylate, which can then attack an alkyl halide. Another common role for potassium carbonate is as an acid scavenger. Many organic reactions produce an acidic byproduct, like hydrochloric acid, HCl. This acid can cause unwanted side reactions or even destroy your desired product. By adding K2CO3 to the reaction mixture, it's there to simply neutralize any acid that forms, keeping the reaction environment stable and improving your yield. Finally, K2CO3 has a completely different job. It can be used as a drying agent. After an aqueous workup, you'll have an organic layer that still has some water dissolved in it. You can add solid, anhydrous potassium carbonate to the solution. It will absorb the water, helping to dry your organic solvent. You just have to be careful not to use it if your product is acidic, because as a base, it would react with it. So, to recap, potassium carbonate is a chemist's multi-tool, a selective base for deprotonating phenols and acids, a key ingredient for making nucleophiles in ether and ester synthesis, an acid scavenger to protect your reactions, and a basic drying agent. It's a cheap, safe, and incredibly effective reagent. Thank you so much for watching. I hope this video helped clarify the role of this important chemical. If you found this helpful, please consider liking the video and subscribing to the channel. Your support really helps me create more content like this for everyone. See you in the next video.